Okay, so let's solve a problem, which is an example from Giancoli's book, 6 editions, the example 1215. Okay, so what is this problem? We have a sound wave that is emitted from a stationary source. So here we have our stationary source. And the sound wave has this frequency 5,000 hertz. Okay, it's emitted from the stationary source, and then it is going to hit someone, an observer, that is moving towards toward the source. Okay, so this is the source here, stationary, and we have this observer moving toward the source. This is the first part. The speed of this observer, let's put it here, is 3.5 meters per second. Okay, 3.50 meters per second. Let me correct this. 3.50 meters per second. Okay, first thing that I want to know is what is the frequency that this person will hear? What is this new frequency that this person will hear because she's moving toward the source? This is what we already derived. Now, to obtain that new frequency, since we have the observer moving toward the source, we would use this equation, which is 1 plus speed of the observer divided by the speed of sound multiplied by the frequency. Yeah. So if we put all the numbers here, we are going to get the frequency that this person is going to hear. So I'll call this the frequency that the observer hears is the F prime. This will be, if you put the numbers, you will find 5051 hertz. Okay, all right. Now, this is what the person in that car hears, but the wave will hit that the front of the car and will get reflected. Okay, so this frequency here becomes now, with this reflection, this becomes the frequency of a new source. It's now the car is the source. And so this is the frequency of a source that is moving to the left. Okay. And now our question is, if we have someone here, what is the frequency that this person here will hear? Cause, no, what is this frequency that this person will hear caused by the reflection of the sound wave? Okay, so our question is, what is this new frequency here? So to obtain this new frequency that this person will hear, we have to go back to that equation of source moving. What is the source now? The car. Yeah, the car that is moving where the wave is getting reflected. So to get this new frequency, what are we going to use? This equation. I'm putting here F prime because I'm thinking about the car as being the source. And here we have 1 minus V of the source divided by V of sound. Okay, so if we put the numbers here, what are the numbers that we're going to put? Here is 5051, which is the new frequency from the car. 1 minus, the car is now behaving as a source. It has the speed 3.5 and the speed of sound 353. And with that, we get this final frequency that the person will be detecting. The person who is close to that original source, and this person will hear this new frequency 5103 hertz. So this is an interesting problem. Now, if we compare this frequency with the original frequency from the source, we see that we have a shift of 103 hertz. Yeah? So that's the end of the problem.